Hello everyone, welcome to this video. I, Amrish Kumar Yadav, final year student of BTech Civil Engineering from Faculty of Engineering and Technology, University of Lucknow. I am pleased to present my seminar on the topic of Reclaimed Asphalt Pavement, also known as RAP. RAP is an important innovation in the field of road construction, offering both environmental and economic benefits. But why does RAP matter? As our infrastructure grows, so does the demand for the materials like aggregate and asphalt cement. This demand places immense pressure on natural resources, which are infinite. RAP offers a reduce this pressure while promoting sustainable practices. Now, for the next few minutes, I'll take you through what RAP is, how it processed, its applications, benefits, two fascinating case studies, and differences. Let's get started. Introduction to RAP. Let's start with what RAP is. Simply put, it's old asphalt pavement that has been removed, processed, and recycled for reuse. This practice began in the 1970s in the United States and has grown significantly since then. Why is RAP important? It helps reduce the need for new materials, conserves natural resources, and minimize landfill waste. The processed material can be reused in roads, highways, and parking lots, making it a practical and environmentally friendly solution for modern infrastructure. RAP processing. Now let's talk about how RAP is prepared. The process is straightforward but requires precision to ensure quality. Removal. Old asphalt is removed from roads using specialized machinery like asphalt grinders. Material is transported to a processing facility. Next process is crushing. At the facility, the material is crushed into smaller, manageable pieces to increase its surface area. Next is screening. This crushed material is screened to separate aggregates from asphalt binder. This ensures consistency in quality. Next is stockpiling. Finally, the process wrap is stockpiled and stored until it's ready to be used in new construction projects. Every step ensures that the recycled material maintains its structural integrity and performance. Now, these are some images showing how reclaimed asphalt pavement is processed. Figure 3 showing the removal of existing asphalt pavement with the help of small slip loader and loading it into the dumper for the transportation to the processing facility. Figure 4 is showing crushing of recycled material. Figure 5 is showing screening of crushed material by passing it through different sized screens. And figure 6 is showing the processed recycled material which is stockpiled for transporting it to the construction site. Application of RAP. RAP is incredibly versatile. Let's look at how it's used. In new asphalt pavement, RAP is blended into fresh asphalt mixes, reducing the need for virgin materials. This is its most common use. In base course, RAP provides a stable foundation for roads and highways. Shoulder construction, it's used to construct durable road shoulders that withstand wear and tear. Pavement rehabilitation. RAP is applied to old pavements to extend their lifespan. This is both economical and sustainable. In drainage system, its porous nature makes it ideal for water drainage. In noise reduction, highway constructed with RAP can absorb sound, reducing noise pollution. In air construction, RAP is used in airport runways and taxiways due to its durability. Each of these applications highlights RAP's flexibility and value in modern construction. Benefits of RAP. Now, why should we invest in RAP? Conservation of natural resources. Using RAP means we don't need to extract as many virgin materials, preserving these resources for future generations. Environmental benefits. Recycling asphalt reduces landfill waste, lower energy consumption, and cuts down greenhouse gas emission. Cost saving wrap is more affordable than virgin materials, leading to significant cost reduction in construction projects. Improved pavement performance. Roads with wrap tend to be more durable with better resistance to cracking and rutting. When you combine these benefits, it's clear that wrap isn't just good for the environment, it's also good for business. Case study 1, Wrap in Mumbai. Let me share an example of Wrap in action. In 2021 to 2022, the Western Express Highway in Mumbai was rehabilitated using 25% of Wrap. This project covered a 10-kilometer stretch and aimed to reduce costs while promoting sustainability. However, there were challenges. Material quality. Wrap sourced from different sites varied in quality, for which they performed comprehensive testing of wrap for performance metrics including gradation, blender content, and moisture susceptibility. Next challenge was public awareness. Stakeholders were unfamiliar with benefits of wrap, for which they conducted workshops and seminars to educate stakeholders about the advantages of using wrap in road construction. The next challenge faced was technical expertise, lack of local knowledge about the latest wrap technologies and best practices, for which they collaborated with local engineering institutions to provide training on the applications of wrap technologies. Next challenge was regulatory compliance, ensuring adherence to the guidance set by the Ministry of Road Transport and Highways for using recycled materials, for which they engaged with MORTH and local authorities to ensure compliance with all regulations and guidelines. The next challenge was weather conditions. Mumbai's monsoon season delayed construction, for which they developed a flexible construction schedule to accommodate weather conditions using rapid drying technologies and proper drainage systems. The results were impressive: 20% reduction in material cost, 3,000 tons of asphalt waste diverted from landfills, 80% public approval, lower cracking and surface wear on wrap sections after a year. This case shows how wrap can succeed even in challenging conditions. Case study 2, Wrap in Seattle. Now let's move to Seattle, where wrap was used for a 5-mile stretch of State Route 99 in 2018 to 2019. Here, 30% wrap was incorporated into the asphalt mix. The challenges were different. Material degradation, wrap quality varied due to prior use, for which they conducted extensive laboratory testing, for example, superpave mix design, to determine the best wrap blending and performance. The next challenge was public skepticism. People doubted the reliability of recycled materials, for which they implemented a public outreach campaign, including information session and demonstration to educate the community about wrap benefits. The next challenge was technical expertise, limited knowledge in the local workforce about best practices for using wrap, for which they partnered with local trade schools to provide training workshops on wrap application and handling. The next challenge was strict regulations. The project had to comply with stringent environment standards, for which they worked closely with the Washington State Department of Transportation to ensure compliance with environmental regulations. The next challenge was weather conditions. Seattle's rainy climate posed challenges during construction and material application, for which they developed contingency plans for construction during inclement weather, including temporary shelters and drainage solutions. The project achieved 30% cost saving, 5,000 tons of asphalt waste recycled, improved pavement durability, and reduced cracking. Seattle experience shows how wrap can thrive under strict conditions with proper planning. To sum up, wrap is a game changer for sustainable road construction. It conserves resources, reduces cost, and delivers durable infrastructure. The case studies in Mumbai and Seattle prove that with the right strategies, RAP can overcome challenges and deliver remarkable results. Finally, I would like to acknowledge sources that has contributed to this presentation. The reference is shown below are from various research papers and studies. I hope this presentation has provided valuable insight. Thank you.